Question 1. Cost-benefit analysis shows that using a less expensive, non-certified PVC pipe for a new underground drainage system would save the client money upfront. However, the plumbing code explicitly requires the use of Schedule 40 or Schedule 80 ABS or cast iron for such applications. What is the most responsible and legally compliant course of action for the licensed plumber? Option A. Install the non-certified PVC pipe, as the cost savings are significant and the material appears functionally adequate for drainage. Option B. Install the Schedule 40 or Schedule 80 ABS or cast iron pipe as required by the plumbing code, despite the higher initial cost. Option C. Substitute a different type of unlisted plastic pipe that is cheaper than the approved option, assuming it can handle the drainage load. Option D. Use the non-certified PVC pipe, but document that the client requested it to waive liability. Correct answer is A. Install the non-certified PVC pipe, as the cost savings are significant and the material appears functionally adequate for drainage. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a plumber to balance immediate cost savings against long-term public health and safety, as mandated by plumbing codes. The temptation to use a less expensive, non-compliant material for a drainage system can be significant, but the potential consequences of failure, including property damage, health hazards from sewage backup, and legal liability, are severe. A plumber must exercise sound judgment and prioritize adherence to regulations over short-term financial gains. Correct approach analysis. The correct approach involves selecting materials that meet or exceed the minimum standards set by the applicable plumbing code for drainage systems. This ensures the system's integrity, durability, and ability to safely convey waste without leakage or obstruction. Adherence to the code is not merely a suggestion, but a legal requirement designed to protect public health and welfare. Using approved materials is a fundamental aspect of responsible plumbing practice, preventing future costly repairs and potential health crises. Incorrect approaches analysis. Choosing a cheaper, unapproved material for the drainage system represents a direct violation of plumbing codes. This failure to comply with regulatory standards is ethically unsound and legally risky, as it compromises the safety and functionality of the plumbing system. It prioritizes immediate cost reduction over long-term performance and public safety, which is a dereliction of professional duty. Opting for a material that is not listed or approved by the relevant plumbing authority, even if it appears functionally similar, is also an incorrect approach. Plumbing codes specify approved materials for a reason, often related to their resistance to corrosion, pressure, and chemical breakdown within a drainage environment. Deviating from these specifications without proper testing and approval by the code authority introduces unknown risks and potential system failures. Ignoring the specific requirements for drainage system materials in favor of general plumbing material knowledge is another incorrect approach. Drainage systems have unique demands, such as resistance to solids, potential for gas buildup, and the need for smooth internal surfaces to prevent blockages. General knowledge is insufficient. Specific code compliance for drainage is paramount. Professional reasoning. Professionals should employ a decision-making framework that prioritizes regulatory compliance and public safety above all else. This involves 1. Identifying the specific project requirements and the applicable plumbing code. 2. Researching and verifying that all proposed materials and methods are explicitly permitted by the code for the intended application, in this case, drainage systems. 3. Considering the long-term implications of material choices, including durability, maintenance, and potential health risks. 4. Consulting with code officials or experienced peers if there is any ambiguity regarding material approval or application. 5. Documenting all decisions and justifications, especially when deviating from standard practice, which should only be done with explicit code approval. Question 2. Quality control measures reveal that a plumbing contractor, when installing a new irrigation system for a residential property, has connected the irrigation supply directly to the main potable water line without installing a required backflow prevention device, citing the client's desire to avoid the perceived aesthetic impact and cost of the device. Based on standard plumbing licensing exam jurisdiction regulations for water supply, what is the most appropriate professional action for the contractor to take? Option A. Advise the client that while a backflow preventer is technically required, it is a low-risk situation and they can proceed at their own discretion. Option B. Immediately disconnect the irrigation supply from the potable water line and inform the client that a code-compliant backflow prevention device must be installed before the system can be reconnected. Option C. Proceed with the installation as requested by the client, documenting the client's verbal authorization to waive the backflow prevention requirement. Option D. Install a less expensive, non-certified device that the client believes will be sufficient, and inform the client that it meets their aesthetic and cost concerns. The correct answer is B. Immediately disconnect the irrigation supply from the potable water line and inform the client that a code-compliant backflow prevention device must be installed before the system can be reconnected. Explanation. This scenario presents a professional challenge because it requires a plumbing contractor to balance immediate client demands with long-term public health and safety obligations mandated by water supply regulations. The contractor must exercise careful judgment to ensure compliance without alienating a client who may be unaware of or resistant to regulatory requirements. The core of the challenge lies in interpreting and applying specific water supply regulations to a practical, on-site situation where a deviation from standard practice is proposed. The correct approach involves a thorough understanding of the relevant water supply regulations and their intent. This approach prioritizes adherence to the established standards for water quality and safety, even if it means explaining to the client why the proposed modification cannot be implemented. The regulatory justification stems from the fundamental purpose of water supply regulations: to protect public health by preventing contamination and ensuring the delivery of safe potable water. This includes requirements for backflow prevention, material compatibility, and proper installation to avoid cross-connections or the introduction of harmful substances into the potable water system. A professional plumber has a legal and ethical duty to uphold these standards. An incorrect approach that prioritizes immediate client satisfaction over regulatory compliance is professionally unacceptable. This failure occurs because it directly contravenes the established legal framework designed to safeguard public health. For instance, bypassing a required backflow prevention device, even at the client's request, creates a significant risk of contamination. This action violates the principle of due diligence and exposes the contractor to potential legal penalties, license revocation, and civil liability. Another incorrect approach, such as attempting to find a loophole or a less stringent interpretation of the regulations without proper consultation or understanding, demonstrates a lack of professional integrity and competence. This can lead to unintended consequences and noncompliance, as the spirit of the regulation is often as important as its letter. The professional decision-making process for similar situations should involve a systematic evaluation. First, identify the specific regulatory requirements applicable to the situation. Second, assess the client's request against these requirements. Third, if the request conflicts with regulations, clearly and professionally communicate the regulatory obligations and the reasons for non-compliance to the client, offering compliant alternatives. Fourth, document all communications and decisions. This process ensures that public safety and regulatory adherence remain paramount while maintaining professional client relationships. Question 3. The risk matrix shows a moderate likelihood of project delays due to unforeseen issues during the permitting and inspection phases for a significant residential plumbing upgrade. As the licensed plumber, what is the most responsible and compliant approach to managing this risk? Option A. Focus solely on completing the physical installation of the plumbing system as quickly as possible, leaving the client to handle the permitting and inspection process independently to avoid any potential delays on the plumber's part. Option B. Inform the client that permitting and inspections are often bureaucratic hurdles that can be navigated more efficiently by starting work and addressing any inspector concerns as they arise, potentially without formal permit submission. Option C. Proceed with the majority of the plumbing work, informing the client that inspections can be scheduled later to minimize initial disruption, and hope that any minor issues are overlooked. Option D. Advise the client that permitting and inspections are standard procedures, and that the project timeline will account for these necessary steps, ensuring all applications are submitted promptly and inspections are scheduled proactively. The correct answer is D. Advise the client that permitting and inspections are standard procedures and that the project timeline will account for these necessary steps, ensuring all applications are submitted promptly and inspections are scheduled proactively. Explanation. This scenario presents a common challenge for licensed plumbers navigating the permitting process and ensuring compliance with inspection requirements while managing client expectations and project timelines. The professional challenge lies in balancing the need for thoroughness and adherence to regulations with the client's desire for expediency. A licensed plumber must understand that the permitting process is not merely a bureaucratic hurdle, but a critical safety mechanism designed to protect public health and welfare. Inspections are the enforcement arm of these regulations, ensuring that work is performed to code and that potential hazards are identified and rectified before they can cause harm. The correct approach involves proactively engaging with the permitting and inspection process, understanding that it is an integral part of responsible plumbing practice. This means obtaining the necessary permits before commencing work, scheduling inspections at the required stages, and being prepared to address any issues identified by the inspector. This approach is ethically and regulatorily sound because it prioritizes public safety and demonstrates professional integrity by adhering to the established legal framework governing plumbing work. It also protects the plumber from potential liability and disciplinary action. An incorrect approach that bypasses or minimizes the permitting and inspection process is professionally unacceptable. This could manifest as starting work without a permit, assuming an inspection is not necessary for minor alterations, or attempting to conceal work from inspectors. Such actions represent a direct violation of plumbing codes and licensing regulations. Ethically, it undermines the trust placed in licensed professionals to uphold safety standards. Regulatory failures include noncompliance with specific statutes and ordinances governing construction and plumbing, which can lead to fines, stop work orders, and license suspension or revocation. Professionals should adopt a decision-making framework that prioritizes regulatory compliance and public safety. This involves 1. Thoroughly understanding the permitting and inspection requirements for the specific jurisdiction and type of work. 2. Communicating these requirements clearly to the client, managing their expectations regarding timelines and potential costs associated with the process. 3. Proactively initiating the permitting process and scheduling inspections at appropriate junctures. 4. Maintaining open communication with building officials and inspectors. 5. Documenting all permit applications, approvals, and inspection reports. Question 4. The control framework reveals a plumbing installation requiring the distribution of both hot and cold potable water within a residential dwelling. The installer is considering using CPVC piping for the hot water lines and standard PVC for the cold water lines. For the CPVC hot water lines, the installer plans to use a universal solvent cement and primer and intends to test the system for leaks shortly after completing the solvent cementing process. Which of the following approaches best aligns with regulatory requirements and best practices for this scenario? Option A. Use standard PVC piping for both hot and cold water distribution, joined with a universal solvent cement and primer. Option B. Install CPVC piping for hot water distribution, using a solvent cement and primer specifically formulated for CPVC, but proceed with system testing immediately after joining the pipes. Option C. Employ CPVC piping for hot water distribution, joined with a solvent cement and primer designed for standard PVC, and immediately pressurize the system after joining. Option D. Utilize CPVC piping for hot water distribution, employing a solvent cement and primer specifically formulated for CPVC, and allowing for the manufacturer-recommended cure time before pressurizing the system. The correct answer is D. Utilize CPVC piping for hot water distribution, employing a solvent cement and primer specifically formulated for CPVC, and allowing for the manufacturer-recommended cure time before pressurizing the system. Explanation. This scenario presents a common challenge in plumbing installations where multiple piping materials might be considered for a specific application. The professional challenge lies in selecting the appropriate piping material and joining method that not only meets the immediate functional requirements, but also strictly adheres to the governing plumbing codes and manufacturer's specifications. Failure to do so can lead to system failures, code violations, and potential safety hazards. Careful judgment is required to balance material properties, application suitability, and regulatory compliance. The correct approach involves selecting CPVC piping for hot water distribution and employing the appropriate solvent cement and primer specifically designed for CPVC, ensuring proper curing time as per manufacturer instructions. This is the best professional practice because plumbing codes, such as the International Plumbing Code (IPC) or Uniform Plumbing Code (UPC), which are commonly adopted in U.S. jurisdictions for plumbing licensing exams, explicitly permit CPVC for hot and cold water distribution systems up to certain temperature and pressure ratings. Furthermore, manufacturers' installation instructions are considered an integral part of the code and provide critical details on proper joining techniques, including the type of solvent, cement, and primer required for CPVC and the necessary cure times to achieve a strong, leak-free joint. Adhering to these guidelines ensures the long-term integrity and safety of the plumbing system. An incorrect approach would be to use standard PVC piping for hot water distribution. This is a regulatory and ethical failure because standard PVC is not rated for the temperatures typically encountered in hot water systems and can degrade, soften, or even fail under such conditions, leading to leaks and potential water damage. Violates the fundamental principle of using materials for their intended application as specified by codes and manufacturers. Another incorrect approach would be to use a solvent cement designed for standard PVC on CPVC piping. This is a regulatory and ethical failure because the chemical composition of solvent cements is specific to the type of plastic they are designed to join. Using the wrong cement will not properly fuse CPVC, resulting in weak joints that are prone to leaks and failure, thereby violating code requirements for secure and durable piping systems. A third incorrect approach would be to rush the curing process by pressurizing the system immediately after joining the CPVC pipes. This is a regulatory and ethical failure because solvent cement joints require adequate cure time to achieve their full strength. Pressurizing the system prematurely can compromise the integrity of the joint, leading to immediate leaks or future failures, which directly contravenes code mandates for reliable and safe plumbing installations. The professional decision-making process for similar situations should involve a thorough review of the project's requirements, including water temperature and pressure. This should be followed by consulting the applicable plumbing codes and manufacturers' installation guides for the specific piping materials being considered. Always prioritize materials and methods that are explicitly permitted and recommended by both codes and manufacturers for the intended application. When in doubt, seek clarification from code officials or the material manufacturer. Question 5. What factors determine the specific plumbing code requirements that a licensed plumber must adhere to when performing work within a particular municipality, considering potential variations from the state-level plumbing code? Option A. The plumber's personal interpretation of best plumbing practices, irrespective of official codes. Option B. The adopted state plumbing code, along with any officially published local amendments, ordinances, or specific interpretations by the local building department. Option C. The plumbing code requirements that were in effect at the time the plumber obtained their initial state license. Option D. The most recent edition of the National Plumbing Code, regardless of state or local adoption. The correct answer is B. The adopted state plumbing code, along with any officially published local amendments, ordinances, or specific interpretations by the local building department. Explanation. This scenario is professionally challenging because plumbing work is subject to a dual layer of regulation, state-level licensing and plumbing codes, and local amendments that can significantly alter requirements. A plumber must not only possess a valid state license, but also demonstrate a thorough understanding of and adherence to the specific building codes and ordinances adopted by the municipality where the work is to be performed. Failure to do so can result in failed inspections, costly rework, fines, and potential disciplinary action against the license. Careful judgment is required to navigate these potentially overlapping and sometimes conflicting regulations. The correct approach involves actively seeking out and understanding local amendments to the state plumbing code. This demonstrates due diligence and a commitment to compliance. Specifically, this means consulting the local building department's adopted codes, ordinances, and any published interpretations or amendments. This proactive step ensures that the plumbing design and installation meet all applicable requirements, preventing future issues and maintaining professional integrity. An incorrect approach would be to assume that compliance with the state plumbing code alone is sufficient. This overlooks the critical role of local authorities in tailoring regulations to their specific needs and conditions. This failure to investigate local variations constitutes a direct violation of the principle of adhering to all applicable laws and regulations, potentially leading to non-compliant installations and legal repercussions. Another incorrect approach is to rely solely on the advice of a general contractor or another tradesperson regarding local code requirements. Collaboration is important. The ultimate responsibility for code compliance rests with the licensed plumber. Delegating this critical research and understanding to another party without independent verification is a dereliction of professional duty and can lead to errors if the other party's understanding is incomplete or inaccurate. Finally, an incorrect approach is to proceed with installation based on past experience in other jurisdictions. Plumbing codes, especially local amendments, can vary significantly even between neighboring municipalities. Relying on outdated or irrelevant knowledge from previous projects in different areas is a recipe for non-compliance and professional failure. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the governing state plumbing code and licensing requirements. 2. Immediately upon being awarded a project, identify the specific municipality where the work will occur. 3. Contact the local building department or relevant authority to ascertain which version of the state plumbing code has been adopted and what local amendments or ordinances are in effect. 4. Review all relevant local documents thoroughly. 5. Incorporate any identified local variations into the plumbing design and installation plan. 6. Document all research and communication regarding local code requirements. 7. Ensure all work is inspected and approved by the local building department. Question 6. Examination of the data shows a plumbing contractor is tasked with replacing a section of hot and cold water supply piping in a residential dwelling. The existing piping is galvanized steel, but the contractor has identified several options for replacement materials. The contractor must select the most appropriate material and installation method that ensures compliance with all applicable regulations and manufacturer guidelines for a safe and durable system. Option A. Select copper tubing that is rated for potable water systems and install it according to the manufacturer's recommended soldering or press-fitting procedures, ensuring all connections are made in accordance with the local plumbing code. Option B. Choose PEX tubing that is readily available and less expensive than copper, and install it using standard crimp fittings, assuming it will be acceptable as long as it carries a NSF/ANSI 61 certification. Option C. Opt for CPVC piping, which is known for its corrosion resistance, and install it using solvent cement, prioritizing speed of installation to reduce labor costs. Option D. Use a flexible corrugated stainless steel tubing, CSSD, designed for potable water, installing it with the manufacturer's specified fittings, and verify that the CSSD system is listed by an independent testing laboratory for potable water applications and meets all local code requirements. Correct answer is A. Select copper tubing that is rated for potable water systems and install it according to the manufacturer's recommended soldering or press-fitting procedures, ensuring all connections are made in accordance with the local plumbing code. Explanation. Scenario analysis. This scenario presents a common challenge in plumbing installations where a contractor must select appropriate materials and methods that comply with local plumbing codes and manufacturer specifications. The professional challenge lies in balancing cost-effectiveness with safety, durability, and code compliance. A failure to adhere to these standards can lead to system failures, property damage, health hazards, and significant legal and financial repercussions for the plumber and the property owner. The plumber must exercise sound judgment to ensure the installation is not only functional, but also meets all regulatory requirements and industry best practices. Correct approach analysis. The correct approach involves selecting materials and installation methods that strictly adhere to the applicable plumbing code and the manufacturer's installation instructions. This is paramount because plumbing codes are established to protect public health and safety by setting minimum standards for materials, design, and installation. Manufacturer instructions are equally critical as they provide specific guidance on how to properly install their products to ensure optimal performance and longevity, and often incorporate safety features or limitations not fully detailed in the general code. By prioritizing both, the plumber ensures a safe, compliant, and reliable installation that minimizes the risk of failure and liability. Incorrect approach is analysis. Choosing materials solely based on cost without verifying code compliance or manufacturer recommendations is a significant regulatory and ethical failure. This approach prioritizes profit over safety and compliance, potentially leading to the use of substandard or incompatible materials that could fail prematurely or create hazards. Selecting materials based on past experience or familiarity, even if those materials were previously acceptable, without confirming current code requirements and manufacturer specifications, is also problematic. Codes and manufacturer guidelines are updated to reflect new technologies, safety concerns, and material science. Relying on outdated knowledge can result in non-compliant installations. Using materials that meet code but disregarding manufacturer installation instructions is another failure. Manufacturers design their products with specific installation parameters to ensure proper function and safety. Deviating from these instructions can void warranties, compromise the integrity of the system, and potentially create unsafe conditions, even if the materials themselves are code-approved. Professional reasoning. Professionals should approach material selection and installation by first identifying the governing plumbing code for the jurisdiction. Then, they must consult the manufacturer's installation instructions for all specified components. A systematic review of these documents will reveal any conflicts or specific requirements. When conflicts arise, the more stringent requirement, whether code or manufacturer, should generally be followed, or clarification sought from the code authority or manufacturer. A commitment to ongoing education regarding code updates and new product technologies is essential for maintaining professional competence and ensuring compliance. Question 7. When evaluating the organizational structure of the plumbing code to determine the correct installation requirements for a new residential drainage system, which approach best ensures comprehensive compliance and avoids potential omissions? Option A. Relying on past project experience and general plumbing knowledge to infer the most likely correct requirements, only consulting the code if a specific doubt arises. Option B. Prioritizing information from online forums and trade publications that discuss common drainage system installations, using the code as a secondary reference for clarification. Option C. Randomly browsing through different chapters of the code, hoping to stumble upon the relevant information for drainage system installation. Option D. Systematically referencing the code's table of contents and index to locate specific chapters and sections related to drainage, venting, and pipe sizing, then following the outlined subsections and cross-references within those identified areas. Correct answer is D. Systematically referencing the code's table of contents and index to locate specific chapters and sections related to drainage, venting, and pipe sizing, then following the outlined subsections and cross-references within those identified areas. Explanation. When evaluating code organization and structure for a plumbing project, a licensed plumber faces the professional challenge of ensuring compliance with safety standards, efficient installation, and clear documentation for future maintenance. Misinterpreting or misapplying code structure can lead to significant safety hazards, costly rework, and potential legal liabilities. The complexity arises from the interconnectedness of different code sections and the need to apply them contextually to specific installation scenarios. The correct approach involves systematically navigating the plumbing code's established hierarchy and indexing to locate relevant sections pertaining to the specific work being performed. This method ensures that all applicable requirements, from material specifications to venting and drainage, are identified and addressed in the correct order of precedence as outlined within the code structure. This systematic approach is ethically and regulatorily mandated by the plumbing licensing exams governing framework, which emphasizes adherence to the codified standards for public safety and health. An incorrect approach of randomly searching for information or relying solely on memory without consulting the code's organized structure risks overlooking critical provisions. This failure to follow the code's intended organizational framework can lead to non-compliance, potentially violating specific sections related to pipe sizing, fixture clearances, or trap requirements, thereby compromising the integrity and safety of the plumbing system. Another incorrect approach is to prioritize personal experience or common practice over the explicit requirements found within the code's organized sections. While experience is valuable, it cannot supersede the legally binding regulations. Failure to consult and apply the code's structured guidance constitutes a direct violation of the licensing requirements and ethical obligation to uphold established safety standards. Professionals should employ a decision-making process that begins with clearly defining the scope of work. They should then utilize the code's table of contents, index, and chapter headings to pinpoint the most relevant section. Cross-referencing is crucial, but it must be done within the context of the code's established structure. If ambiguity arises, consulting the code's appendices or official interpretations, if available and permitted by the jurisdiction's framework, is the appropriate next step, rather than making assumptions or deviating from the codified order. Question 8. Market research demonstrates that property owners often seek the most cost-effective and least intrusive solutions for plumbing issues. A licensed plumber is called to a commercial property with a landscape irrigation system connected to the potable water supply. The property owner requests the installation of a simple shut-off valve to isolate the irrigation system when not in use, believing this will suffice for cross-connection control. Based on best practices and regulatory requirements for plumbing licensing exams, which of the following represents the most appropriate professional response? Option A. Install a reduced pressure zone, RPZ backflow preventer, as this is a high-hazard device suitable for most commercial applications and ensures maximum protection. Option B. Install a pressure vacuum breaker, PVB backflow preventer, as it is a common and effective device for preventing backsiphonage in irrigation systems. Option C. Install a simple shut-off valve as requested by the property owner, with a note on the invoice that it is not a code-compliant backflow prevention method. Option D. Install an atmospheric vacuum breaker, AVB backflow preventer, as it is a simpler and less expensive option that meets the requirements for preventing backsiphonage in this scenario. The correct answer is A. Install a reduced pressure zone, RPZ backflow preventer, as this is a high-hazard device suitable for most commercial applications and ensures maximum protection. Explanation: this scenario is professionally challenging because it requires a plumber to balance immediate client requests with long-term public health and safety obligations mandated by plumbing codes. The plumber must understand that while a client may desire a quick fix, the integrity of the potable water supply is paramount and cannot be compromised by inadequate or non-compliant backflow prevention measures. The core of the challenge lies in interpreting and applying the relevant plumbing code provisions for cross-connection control, even when faced with potential client dissatisfaction or perceived inconvenience. The correct approach involves a thorough understanding and strict adherence to the plumbing code's requirements for backflow prevention devices. This means identifying the specific hazard level of the cross-connection, e.g., high hazard, low hazard, and selecting, installing, and testing a device that meets or exceeds the code specifications for that hazard. Regulatory justification stems directly from plumbing codes that establish standards for potable water protection to prevent contamination. Ethically, a plumber has a duty to protect public health, which overrides a client's desire for a less compliant or substandard solution. An incorrect approach of installing a simple shut-off valve without a proper backflow prevention device fails to address the potential for backsiphonage or backpressure, leaving the potable water system vulnerable to contamination. This is a direct violation of plumbing codes that mandate specific prevention methods for identified cross-connections. Another incorrect approach of installing a device not rated for the identified hazard level, even if it is a recognized backflow preventer, is also a code violation. The code specifies performance requirements based on hazard, and using an underspecified device creates an unacceptable risk. Finally, failing to test the installed backflow prevention device after installation, or at the required intervals, is a failure to comply with code requirements for ongoing protection and verification of the device's functionality, thereby compromising the integrity of the cross-connection control. Professionals should employ a decision-making framework that prioritizes code compliance and public safety. This involves 1. Accurately identifying and assessing the cross-connection and its associated hazard level according to code definitions. 2. Consulting the specific sections of the plumbing code pertaining to cross-connection control and backflow prevention for the identified hazard. 3. Selecting the appropriate code-approved backflow prevention device. 4. Ensuring proper installation according to manufacturer specifications and code requirements. 5. Performing mandatory testing and documentation. 6. Communicating clearly with the client about the necessity of these measures and the associated costs, framing it as a non-negotiable aspect of protecting public health. Question 9. Benchmark analysis indicates that plumbing contractors frequently encounter requests for services that may border on or extend into other licensed trades. A homeowner asks a licensed plumber to install a new gas line to an outdoor grill, which includes connecting to the main gas supply and running the line through a wall to the patio. The homeowner also asks the plumber to install a new electrical outlet near the grill for a lighting fixture. Based on the typical scope of a plumbing license, which of the following actions best adheres to the regulatory framework and professional standards? Option A. Perform the gas line installation, as it is clearly within the scope of a plumbing license, and inform the homeowner that the electrical work must be done by a licensed electrician. Option B. Perform both the gas line installation and the electrical outlet installation, as both involve working with utilities and are often handled by contractors who perform multiple home services. Option C. Perform the electrical outlet installation, as it is a simple task, and decline only the gas line installation, stating it is too complex. Option D. Perform both installations but inform the homeowner that the electrical work is outside the plumber's license and that they will subcontract it to an unlicensed handyman. Correct answer is B. Perform both the gas line installation and the electrical outlet installation, as both involve working with utilities and are often handled by contractors who perform multiple home services. Explanation: this scenario presents a professional challenge because a plumbing contractor is asked to perform work that falls outside their license scope. The core of the challenge lies in balancing client requests with legal and regulatory boundaries, ensuring public safety, and maintaining professional integrity. A plumbing contractor must understand the precise definitions and limitations of their license to avoid engaging in activities that could lead to legal repercussions, disciplinary action, and potential harm to the public. The correct approach involves clearly communicating the limitations of the plumbing license to the client and declining to perform the work that falls outside the license scope. This is the most professionally sound and legally compliant action. It upholds the regulatory framework by ensuring that only licensed individuals perform work within their designated expertise, thereby protecting public health and safety. Ethically, it demonstrates honesty and integrity by not undertaking work for which the contractor is not qualified or authorized. An incorrect approach would be to attempt the work, believing it to be a minor extension of plumbing services. This is a regulatory failure because it violates the specific scope defined by the Plumbing Licensing Board. It also poses an ethical failure by misrepresenting qualifications and potentially compromising safety. Another incorrect approach would be to perform the work without informing the client that it falls outside the license scope, hoping to avoid issues. This is a significant ethical and regulatory failure, as it involves deception and a disregard for licensing requirements, potentially leading to unsafe installations and legal penalties. Finally, an incorrect approach would be to subcontract the work to an unlicensed individual. This is a direct violation of licensing laws, as the primary contractor remains responsible for the work performed under their license, regardless of subcontracting. It also fails to ensure that the work is performed by a qualified and licensed professional, posing a risk to public safety. Professionals should employ a decision-making framework that prioritizes understanding and adhering to licensing regulations. This involves regularly reviewing the scope of their license, seeking clarification from the licensing board when in doubt, and communicating transparently with clients about what services can and cannot be legally provided. When faced with a request outside their scope, the professional response is to politely decline, and if possible, recommend a licensed professional in the appropriate trade. Question 10. Regulatory review indicates that a homeowner is requesting the installation of a decorative, non-standard shower valve trim that is made of a material not explicitly listed as approved for potable water contact in the local plumbing code. The contractor knows this material is aesthetically desirable to the client, but is concerned about its long-term durability and potential for leaching under constant water exposure, as it is not a recognized plumbing-grade material. What is the most professionally responsible course of action for the plumbing contractor? Option A. Install the requested trim, but advise the client to use it sparingly to minimize potential issues. Option B. Inform the client that the requested trim cannot be installed due to code noncompliance and offer to install a standard code-approved trim. Option C. Install the requested trim, assuming the client understands the risks and is willing to accept them. Option D. Research and present code-approved alternative trim options that closely match the client's desired aesthetic while ensuring compliance with material standards. The correct answer is C. Install the requested trim, assuming the client understands the risks and is willing to accept them. Explanation. This scenario presents a professional challenge because a plumbing contractor is faced with a situation where a client's aesthetic preference for a fixture directly conflicts with the material requirements mandated by local plumbing codes. The contractor must balance client satisfaction with legal and safety obligations. A failure to adhere to code can result in failed inspections, fines, and potential liability. A failure to address the client's concerns can lead to a loss of business and reputational damage. Careful judgment is required to navigate this conflict ethically and legally. The correct approach involves educating the client about the code requirements and the reasons behind them, then offering compliant alternatives that meet both safety standards and the client's aesthetic goals as closely as possible. This demonstrates professionalism, prioritizes safety and compliance, and maintains a good client relationship by actively seeking solutions. Specific regulatory justification lies in the plumbing code's mandate for approved materials and methods to ensure public health and safety. Ethical justification stems from the professional duty to perform work in accordance with all applicable laws and standards. An incorrect approach of installing the non-compliant fixture to satisfy the client immediately is a direct violation of plumbing codes. This failure carries significant regulatory consequences, including failed inspections, potential stop work orders, and fines. Ethically, it breaches the contractor's responsibility to uphold professional standards and public safety. Another incorrect approach of simply refusing to install any fixture without offering alternatives fails to meet the client's needs and demonstrates poor customer service. While it avoids code violation, it does not represent a professional attempt to find a workable solution and can damage the contractor's reputation. A third incorrect approach of attempting to find a loophole or an unapproved method to install the desired fixture is also a regulatory and ethical failure. It involves circumventing established safety standards and could lead to unforeseen problems with the plumbing system, posing a risk to the building occupants and potentially leading to legal liability. The professional reasoning process for such situations should involve 1. Thoroughly understanding the client's request and underlying needs. 2. Consulting the relevant plumbing codes and regulations to determine compliance. 3. Identifying any conflicts between the request and the code. 4. Communicating the code requirements clearly and respectfully to the client, explaining the rationale. 5. Proactively researching and presenting compliant alternatives that address the client's aesthetic preferences. 6. Documenting all communications and decisions. Question 11. Compliance review shows that a plumbing contractor, while performing rough-in plumbing for a new residential building, has deviated from the approved plans by installing a drain pipe in a location that obstructs a required ventilation pathway. The deviation was not reported to the plumbing inspector. What is the most appropriate immediate course of action for the contractor? Option A. Continue with the installation as planned, assuming the inspector will not notice the deviation during the final inspection. Option B. Discreetly alter the approved plans to reflect the new pipe location and proceed with the installation. Option C. Complete the rough-in plumbing for the entire building and then inform the inspector of the deviation during the final inspection. Option D. Immediately stop all work on the affected section, document the deviation and its potential safety implications, and formally notify the plumbing inspector for guidance. The correct answer is D. Immediately stop all work on the affected section, document the deviation and its potential safety implications, and formally notify the plumbing inspector for guidance. Explanation. Scenario analysis. This scenario presents a common challenge in plumbing compliance. A discrepancy between observed work and approved plans, coupled with a potential safety hazard. The challenge lies in balancing the need for immediate correction of a safety issue with the procedural requirements of the regulatory framework. A plumber must act decisively to protect public safety, while also adhering to the established process for addressing noncompliance, which often involves documentation and communication with the relevant authority. Failure to do so can result in further violations, fines, and potential harm. Correct approach analysis. The correct approach involves immediately ceasing work on the noncompliant section, documenting the deviation and the safety concern, and formally notifying the plumbing inspector or relevant authority. This is the right course of action because it prioritizes public safety by stopping the potentially hazardous installation. It also adheres to the regulatory framework by initiating the proper channels for addressing noncompliance. The plumbing licensing exam emphasizes adherence to established procedures for reporting and rectifying violations, ensuring that all work is inspected and approved before being concealed. This approach demonstrates professional responsibility and a commitment to upholding the standards set by the licensing body. Incorrect approaches analysis. Continuing work without addressing the deviation and safety concern is a direct violation of the plumbing licensing exam's emphasis on safety and compliance. It bypasses the inspection process and potentially leaves a hazardous installation in place, risking public health and safety. This approach demonstrates a disregard for regulatory requirements and professional ethics. Attempting to conceal the deviation or alter the approved plans to match the work performed is fraudulent and a severe ethical and regulatory breach. This undermines the integrity of the inspection process and deceives the authorities, leading to significant penalties and loss of license. Proceeding with the work and only informing the inspector at the final inspection stage, without prior notification of the deviation, is also problematic. While it eventually brings the issue to light, it fails to address the immediate safety concern and the procedural requirement to report deviations as they occur or before proceeding with concealed work. This approach can lead to costly rework and delays, and may still be considered a violation for not proactively reporting the noncompliance. Professional reasoning. Professionals facing such situations should employ a decision-making framework that prioritizes safety, followed by adherence to regulatory procedures. The framework involves 1. Immediate assessment of safety risks. 2. Halting work on the non-compliant element if a safety risk is identified. 3. Thorough documentation of the observed deviation and the reasons for concern. 4. Formal and timely communication with the designated regulatory authority, e.g., plumbing inspector. 5. Following the authority's guidance for correction and reinspection. This systematic approach ensures that both immediate safety and long-term regulatory compliance are met. Question 12. Compliance review shows a plumbing contractor has installed a specific type of drainage fitting that deviates from the prescriptive requirements of the National Plumbing Code, as adopted by the local jurisdiction. The client has indicated that this fitting was recommended by a previous contractor and that they believe it offers a functional advantage. The plumber proceeded with the installation without seeking a formal variance or consulting the local building department regarding the deviation. Which of the following represents the most appropriate professional response to this situation, considering the plumber's obligation to adhere to local regulations? Option A. The plumber should have documented the client's request and the fitting used, and then submitted this documentation to the local building department after the installation for their review and potential approval. Option B. The plumber should have relied on the client's assurance that the fitting was acceptable, as the client is the property owner and has the right to dictate the materials used in their home. Option C. The plumber should have thoroughly researched the local plumbing code and any adopted amendments or ordinances to determine if a formal variance process exists for such deviations, and if so, followed that process to obtain official approval before proceeding with the installation. Option D. The plumber should have proceeded with the installation as requested by the client, assuming that minor deviations from the code are generally overlooked by inspectors if they do not pose an immediate safety hazard. The correct answer is C. The plumber should have thoroughly researched the local plumbing code and any adopted amendments or ordinances to determine if a formal variance process exists for such deviations, and, if so, followed that process to obtain official approval before proceeding with the installation. Explanation. This scenario is professionally challenging because it requires a plumber to navigate the potential conflict between a client's specific requests and the established plumbing codes, which are designed for public safety and health. The plumber must exercise sound professional judgment to ensure compliance while meeting client needs where permissible. The correct approach involves thoroughly researching and understanding the specific local amendments or variances to the National Plumbing Code that apply to the jurisdiction. This includes verifying if the proposed deviation has been formally approved through a recognized process, such as a variance application or a local ordinance that explicitly permits such a modification under specific conditions. This approach is correct because it prioritizes adherence to the legally binding regulatory framework. Plumbing codes are not suggestions, they are enforceable laws. Any deviation must be sanctioned by the governing authority. This ensures that safety and health standards are maintained, even when a specific situation warrants an exception. Professional ethics also mandate that a plumber operates within the bounds of the law and does not compromise public welfare for client convenience or cost savings. An incorrect approach would be to proceed with the client's requested deviation based solely on the client's assurance that it is acceptable or on a past, unverified instance of a similar deviation. This is incorrect because it bypasses the official regulatory channels for approving code variations. The plumber assumes a significant legal and ethical risk by not confirming the validity of the deviation through the proper authorities. Relying on anecdotal evidence or client claims without official verification is a failure to uphold professional responsibility and could lead to failed inspections, rework, fines, and damage to the plumber's reputation and license. Another incorrect approach would be to implement the deviation without any documentation or formal approval, assuming that because it's a minor change, it won't be noticed or cause issues. This is incorrect because it demonstrates a disregard for the code's intent and enforcement mechanisms. Even minor deviations can have unforeseen consequences on system performance or safety. Furthermore, it constitutes a deliberate act of noncompliance, which is a direct violation of licensing requirements and professional standards. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the client's request and the relevant code provision. 2. Determine if the request constitutes a variation from the standard code. 3. If a variation is proposed, immediately consult the specific local plumbing code and any adopted amendments or ordinances for that jurisdiction. 4. If the code allows for variations under specific circumstances, investigate the formal process for obtaining approval. E.g., variance application. Engineer's report, local authority approval. 5. If the variation is not explicitly permitted or if the approval process is unclear, contact the local building department or plumbing inspector for clarification and guidance. 6. Document all communications, research and approvals or denials related to the proposed variation. 7. Only proceed with the deviation if it is formally approved by the relevant authority and documented accordingly. 8. If the deviation cannot be approved, clearly communicate the code requirements and any alternative solutions to the client. Question 13. The evaluation methodology shows that a plumbing contractor is tasked with installing a new drainage system in a commercial building. During the planning phase, the contractor encounters a situation where the standard drainage and venting requirements in the adopted plumbing code appear to conflict with a specific design element proposed by the architect. The contractor must determine the most appropriate method for proceeding to ensure both code compliance and system functionality. Which of the following approaches best reflects the professional and regulatory requirements for resolving this discrepancy? Option A. Implement a more elaborate and expensive venting system than what is strictly required by the code, believing that this will inherently satisfy any potential code concerns. Option B. Rely on common industry practices and the advice of experienced colleagues, as these often represent practical solutions that may supersede strict code interpretations in complex situations. Option C. Consult the most current adopted plumbing code for the jurisdiction, review relevant sections pertaining to drainage and venting, and if ambiguity persists, seek official interpretation from the local building department or plumbing authority before proceeding with the installation. Option D. Proceed with the installation based on the architect's design, assuming their interpretation of the code is correct, as they are the design professional. The correct answer is C. Consult the most current adopted plumbing code for the jurisdiction, review relevant sections pertaining to drainage and venting, and if ambiguity persists, seek official interpretation from the local building department or plumbing authority before proceeding with the installation. Explanation. This scenario presents a professional challenge because a plumbing contractor is faced with conflicting interpretations of code requirements, potentially leading to either non-compliance or unnecessary, costly work. The challenge lies in accurately identifying the governing code, understanding its intent, and applying it correctly to a specific installation. Careful judgment is required to balance code compliance, client budget, and professional integrity. The correct approach involves a thorough review of the applicable plumbing code for the jurisdiction where the work is being performed. This includes understanding the specific sections related to drainage and venting, and how they are intended to be applied in the given situation. Consulting the official code book and any relevant amendments or interpretations issued by the local building department is paramount. This approach ensures that the installation meets the minimum safety and health standards mandated by law, preventing potential future issues with inspections, system failures, and liability. Adhering strictly to the code is the primary ethical and legal obligation of a licensed plumber. An incorrect approach would be to rely solely on past practices or the opinions of other plumbers without verifying against the current code. This fails to acknowledge that codes are updated and that individual interpretations can be flawed. It risks installing a system that, while perhaps functional in the short term, does not meet the legal requirements, leading to potential fines, rework, and damage to reputation. Another incorrect approach is to prioritize the client's desire for a less expensive solution over code compliance. While client satisfaction is important, it cannot supersede legal mandates for public health and safety. Ignoring code requirements to save money is unethical and illegal, exposing both the plumber and the client to significant risks. A third incorrect approach is to assume that a more complex or expensive method is automatically compliant. While some situations may necessitate more elaborate solutions, the primary focus must always be on meeting the minimum requirements of the code. Over-engineering without a clear code basis can be wasteful and does not guarantee compliance if the fundamental code principles are misunderstood or misapplied. The professional decision-making process for similar situations should begin with identifying the specific jurisdiction and the most current version of the adopted plumbing code. If ambiguity exists within the code itself or in its application to the specific scenario, the next step should be to consult the local building department or plumbing authority for official clarification. Documenting all communications and decisions related to code interpretation is also a crucial professional practice. Question 14. Research into water conservation measures for residential plumbing installations. A licensed plumber is tasked with replacing an old toilet in a client's home. The client expresses a desire to keep costs as low as possible for the replacement. The plumber is aware of the local plumbing code's requirements for water-efficient fixtures. Which approach best balances the client's cost concerns with regulatory compliance and water conservation best practices? Option A. Install a toilet that does not meet the minimum water efficiency standards required by the local plumbing code, as the client prioritized low cost. Option B. Recommend and install a standard flow toilet that is the least expensive option available, regardless of its water efficiency rating. Option C. Recommend and install a low-flow toilet that meets or exceeds the water efficiency standards specified in the local plumbing code. Option D. Inform the client that water conservation measures are optional and can be bypassed if the client does not explicitly ask for them. The correct answer is C. Recommend and install a low-flow toilet that meets or exceeds the water efficiency standards specified in the local plumbing code. Explanation. This scenario is professionally challenging because it requires a plumber to balance client cost expectations with regulatory requirements and best practices for water conservation. The plumber must not only perform the installation correctly, but also advise the client on options that align with water efficiency standards, which may have initial cost implications. Careful judgment is required to ensure the client receives a functional system that also meets legal obligations and promotes sustainable water use. The correct approach involves recommending and installing low-flow fixtures that meet or exceed the minimum water efficiency standards mandated by the relevant plumbing codes. This approach represents best professional practice because it directly addresses the core requirement of water conservation as outlined in plumbing regulations. By selecting fixtures certified for water efficiency, the plumber ensures compliance with legal mandates, promotes responsible resource management, and provides the client with a system that will reduce water consumption and associated utility costs over time. This proactive recommendation demonstrates professional expertise and a commitment to ethical service delivery. Recommending standard flow fixtures without considering water conservation measures is an ethical and regulatory failure. It neglects the explicit requirements for water-efficient installations in many jurisdictions and fails to advise the client on options that could lead to long-term savings and environmental benefits. This approach prioritizes immediate cost savings for the client over compliance and responsible plumbing practices. Suggesting the installation of fixtures that do not meet the minimum water efficiency standards, even if they are cheaper, is a direct violation of plumbing codes and regulations. This action not only exposes the client to potential penalties, but also undermines the purpose of water conservation mandates. It demonstrates a lack of professional integrity and a disregard for legal and environmental responsibilities. Advising the client that water conservation measures are optional and can be ignored if not explicitly requested is a failure to uphold professional duties. Plumbers have a responsibility to be knowledgeable about and adhere to all applicable codes and regulations, including those related to water efficiency. Failing to inform clients about these requirements and their benefits is a dereliction of professional duty and can lead to non-compliant installations. Professionals should approach such situations by first understanding the specific water conservation requirements stipulated by the local plumbing code. They should then assess the client's needs and budget and present a range of compliant options, clearly explaining the benefits and any potential differences in upfront cost versus long-term savings. The decision-making process should prioritize regulatory compliance, followed by client education and informed choice, ensuring that the final installation is both legal and efficient. Question 15. To address the challenge of selecting the most appropriate PEX piping system for a new residential potable water distribution, a licensed plumber is evaluating different combinations of PEX tubing types and their corresponding joining methods. Considering the need for a durable, reliable, and code-compliant installation, which of the following approaches represents the most technically sound and professionally responsible choice? Option A. Utilizing PEX tubing with the solvent cement joining method. Option B. Utilizing PEX tubing with the cold expansion joining method. Option C. Utilizing PEXC tubing with the press joining method. Option D. Utilizing PEXB tubing with the crimp joining method. The correct answer is B. Utilizing PEX tubing with the cold expansion joining method. Explanation. This scenario presents a professional challenge because selecting the appropriate PEX piping type and joining method is critical for ensuring the long-term integrity, safety, and compliance of a plumbing system. Incorrect choices can lead to leaks, premature system failure, water contamination, and significant repair costs, all of which fall under the plumber's responsibility and can result in disciplinary action or loss of license. The challenge lies in understanding the nuances of different PEX types and their compatibility with various joining techniques, as dictated by the governing plumbing codes. The correct approach involves selecting PEX piping and using the cold expansion joining method. This is the correct choice because PEX is known for its superior flexibility and memory, making it easier to install in tight spaces and less prone to kinking. The expansion method, when performed correctly with compatible fittings, creates a strong, reliable, and watertight connection that is specifically designed for PEX and is recognized and permitted by plumbing codes for potable water distribution systems. This method ensures a secure joint that can withstand pressure and temperature fluctuations over time, adhering to the performance standards required by the code. An incorrect approach would be to select PEXB piping and use crimp fittings. This is incorrect because, while PEXB is a common type, it is generally less flexible than PEX and can be more susceptible to kinking. Furthermore, using crimp fittings with PEXB, while a valid joining method for PEXB, might not be the most robust or code-compliant choice in all situations, especially if the specific application demands the superior joint strength and flexibility offered by PEX and its associated expansion method. The failure here is in not selecting the optimal combination of pipe type and joining method for the given application and potentially overlooking code preferences or best practices that favor certain pairings. Another incorrect approach would be to select PEXC piping and use press fittings. PEXC is less common and has different properties than PEX or PEXB. Press fittings are typically used with copper or stainless steel pipe, and their compatibility with PEXC would need to be explicitly verified by the manufacturer and the plumbing code. Using a joining method not specifically designed or approved for the chosen PEX type is a direct violation of code requirements and manufacturer instructions, leading to potentially weak or leaking joints. This represents a failure to adhere to the fundamental principles of material compatibility and code compliance. A final incorrect approach would be to select PEX piping and use solvent cement joining. PEX piping, regardless of type A, B, or C, is not designed to be joined using solvent cement. Solvent cement is used for joining materials like PVC, CPVC, or ABS. Attempting to use solvent cement on PEX would not create a watertight seal and would likely result in immediate failure of the joint, posing a significant safety hazard and a clear violation of plumbing codes and material specifications. This is a fundamental misunderstanding of PEX material properties and joining technologies. The professional decision-making process for similar situations should begin with a thorough understanding of the project's requirements, including water pressure, temperature, and the installation environment. Next, consult the applicable plumbing code, e.g., International Plumbing Code, Uniform Plumbing Code, or state-specific amendments, to identify permitted PEX types and their approved joining methods. Review manufacturer specifications for the chosen PEX product to confirm compatibility with specific fittings and tools. Finally, select the combination of PEX type and joining method that offers the best performance, durability, and code compliance for the specific application, prioritizing safety and longevity. Question 16. Analysis of a situation where a licensed plumber, while installing a drainage system, realizes that a vent pipe has been inadvertently installed with a slope that does not meet the minimum requirements stipulated in the Uniform Plumbing Code, UPC. The plumber knows that correcting this would involve significant rework, delaying the project and incurring additional costs, and is considering whether to proceed with concealing the vent as is, hoping it will pass inspection, or to address the issue. Option A. Proceed with concealing the vent pipe as installed, assuming that minor deviations in slope are often overlooked during inspections and that the system will function adequately. Option B. Complete the installation as is and wait for the final inspection, planning to address any issues only if they are specifically identified by the inspector. Option C. Attempt to modify the vent pipe in a minor way to improve its slope without consulting the building department or informing the client, believing this will resolve the issue without significant disruption. Option D. Immediately halt work on the vent, inform the client of the UPC violation, and contact the local building department to schedule an inspection and discuss corrective measures to bring the vent into full compliance with UPC requirements. The correct answer is D. Immediately halt work on the vent, inform the client of the UPC violation, and contact the local building department to schedule an inspection and discuss corrective measures to bring the vent into full compliance with UPC requirements. Explanation. This scenario presents a professional challenge because it pits a contractor's desire to complete a job quickly and profitably against the paramount responsibility to adhere to established safety and health standards as mandated by the Uniform Plumbing Code, UPC. The contractor is aware of a deviation from code requirements, but is tempted to overlook it to avoid delays and potential cost overruns. This situation demands careful judgment to prioritize public safety and legal compliance over immediate financial gain. The correct approach involves immediately ceasing work on the affected portion of the system and notifying the client and the relevant building department of the code violation. This demonstrates a commitment to ethical conduct and regulatory compliance. Specifically, UPC Section 103.3.1 requires that all plumbing work be installed in accordance with the code, and Section 103.3.2 mandates that the building official shall inspect the work. By self-reporting the deviation, the contractor is proactively addressing the issue, ensuring the system is brought into compliance before it is concealed, and upholding their professional responsibility to protect public health and safety. This aligns with the ethical obligation of licensed plumbers to perform work that meets or exceeds code standards. An incorrect approach would be to proceed with concealing the improperly installed vent pipe. This action constitutes a direct violation of UPC Section 706.3, which specifies the requirements for vent pipe installation and termination. Ethically, it represents a breach of trust with the client and a disregard for public safety, as an improperly installed vent can lead to sewer gas infiltration and health hazards. Another incorrect approach would be to attempt to modify the vent pipe in a way that is not explicitly permitted by the UPC, without consulting the building department or seeking a formal interpretation. This could involve using unapproved materials or methods, which would also violate the code and potentially create an unsafe condition. The UPC provides specific guidelines for all aspects of plumbing installation, and deviations without proper authorization are not permissible. A further incorrect approach would be to ignore the issue and hope it goes unnoticed during inspection. This is not only a violation of the UPC's inspection requirements, Section 103(3)(2), but also a serious ethical lapse. It demonstrates a lack of integrity and a willingness to compromise safety for convenience, which can have severe legal and professional repercussions. The professional decision-making process for similar situations should involve a thorough understanding of the applicable plumbing code, a commitment to ethical practice, and a proactive approach to problem solving. When a potential code violation is identified, the professional should 1. Stop work on the affected area. 2. Consult the relevant sections of the UPC to confirm the violation. 3. Immediately notify the client of the issue and the required corrective action. 4. Contact the local building department for guidance or to schedule an inspection of the non-compliant work. 5. Implement the necessary repairs or modifications to bring the installation into full compliance with the UPC before proceeding or concealing the work. This systematic approach ensures that safety and compliance are always prioritized. Question 17. The investigation demonstrates that a homeowner is requesting the installation of a water softener and a separate whole-house sediment filter system. The homeowner has provided a brochure for a specific brand and model of each unit, indicating their preference. The plumber must determine the most appropriate course of action to ensure compliance with all relevant regulations and best practices. Option A. Recommend a more advanced and expensive filtration system than what the homeowner has requested, believing it will provide superior water quality regardless of the specific documented water issues. Option B. Install the water softener and sediment filter system as specified by the homeowner, assuming the provided brochures represent compliant and effective solutions. Option C. Install the water softener and sediment filter system using the homeowner's preferred units, but modify the installation process to expedite completion, as long as the basic function of the units appears to be met. Option D. Proceed with the installation of the homeowner's preferred water softener and sediment filter system, only after verifying that both units and their proposed installation methods meet all requirements outlined in the applicable state plumbing code and manufacturer installation manuals. Correct answer is B. Install the water softener and sediment filter system as specified by the homeowner, assuming the provided brochures represent compliant and effective solutions. Explanation. This scenario is professionally challenging because it requires a plumber to balance client requests with regulatory compliance and public health considerations when installing water treatment systems. The plumber must ensure that any installed system meets the performance standards and installation requirements mandated by the relevant plumbing codes and health regulations to prevent potential contamination or ineffective treatment. The correct approach involves consulting the applicable plumbing codes and manufacturer's installation guidelines to determine the appropriate sizing, placement, and connection requirements for the water softener and filtration system. This ensures the system operates effectively, complies with all legal mandates, and protects the water supply from potential issues like backflow or cross-contamination. Adherence to these regulations is paramount for public health and safety and for maintaining professional licensure. An incorrect approach would be to install a system based solely on the homeowner's perceived needs or the lowest cost option without verifying code compliance. This could lead to a system that is undersized, improperly installed, or uses unapproved materials, potentially failing to treat the water effectively or even creating health hazards. Such an action would violate plumbing codes and potentially public health statutes, leading to fines, license suspension, and liability for any resulting health issues. Another incorrect approach is to recommend a system that exceeds the documented water quality issues without a clear technical justification. While it might seem like providing a superior solution, it could lead to unnecessary expense for the homeowner and may not be the most efficient or effective method for addressing the specific water problem, potentially violating ethical obligations to provide cost-effective and appropriate solutions. Finally, an incorrect approach would be to bypass or alter manufacturer-specified installation procedures to save time or effort. This directly contravenes manufacturer instructions and often the underlying principles of the system's design, risking system failure, voiding warranties, and potentially creating unsafe conditions, all of which are regulatory and ethical failures. Professionals should approach such situations by prioritizing a thorough understanding of the client's water quality issues, cross-referencing this with applicable local and state plumbing codes, and then selecting and installing a system that meets both the client's needs and all regulatory requirements. This involves a systematic process of assessment, research, selection, and installation, with a constant focus on compliance and client well-being. Question 18. During the evaluation of a new hospital wing construction project, a licensed plumber is tasked with installing the medical gas piping system for oxygen, medical air, and vacuum. The plumber has extensive experience with general plumbing, but limited specific experience with medical gas installations. Which of the following approaches best ensures compliance with regulatory requirements and patient safety? Option A. Reviewing the project's medical gas piping plans against the relevant sections of the International Fire Code and International Mechanical Code, specifically focusing on requirements for medical gas and vacuum systems, and ensuring all installation, material, and testing protocols align with these codes. Option B. Consulting with the general contractor to confirm that standard oxygen piping installation methods are acceptable for all medical gases specified in the project. Option C. Completing the installation and performing only leak testing on the medical gas lines, as this is generally considered sufficient for gas system integrity. Option D. Proceeding with the installation using standard plumbing practices and materials, assuming that general knowledge of gas piping is sufficient for medical gas applications. Correct answer is A. Reviewing the project's medical gas piping plans against the relevant sections of the International Fire Code and International Mechanical Code, specifically focusing on requirements for medical gas and vacuum systems, and ensuring all installation, material, and testing protocols align with these codes. Explanation. This scenario is professionally challenging because it involves the critical safety aspect of medical gas piping, where errors can have life-threatening consequences. A plumber must demonstrate not only technical proficiency, but also a thorough understanding of and strict adherence to specialized regulations that govern these systems. The inherent complexity of medical gas systems, their unique materials, installation methods, and testing requirements necessitates meticulous attention to detail and a commitment to patient safety above all else. The correct approach involves a comprehensive review of the project's medical gas piping plans against the applicable sections of the International Fire Code, IFC, and the International Mechanical Code, IMC, specifically focusing on Article 5001 of the IFC and Chapter 5 of the IMC, which detail requirements for medical gas and vacuum systems. This includes verifying that all materials used are approved for medical gas service, that brazing procedures meet the stringent cleanliness and integrity standards, and that the system has undergone the required pressure and leak testing, as well as purity testing, as mandated by these codes. Adherence to these specific code provisions ensures the safety, efficacy, and purity of the medical gases delivered to patients, directly fulfilling the plumber's ethical and legal obligation to uphold public health and safety. An incorrect approach of proceeding with installation based solely on general plumbing knowledge, without consulting the specific medical gas piping sections of the IFC and IMC, would be a significant regulatory failure. This oversight would likely lead to the use of unapproved materials, improper joining techniques, and a failure to perform essential testing, all of which violate the explicit requirements of the IFC and IMC for medical gas systems. Another incorrect approach, that of assuming that standard oxygen piping practices are sufficient for all medical gases, is also a critical failure. Medical gases have different properties and require specific handling and materials, and the IFC and IMC differentiate these requirements. For instance, the purity standards for medical oxygen are far more stringent than for industrial oxygen. Finally, an approach that skips the final purity testing of the medical gas lines after installation, believing that leak testing is sufficient, represents a dangerous regulatory and ethical lapse. The IFC and IMC mandate purity testing to ensure that no contaminants have entered the system during installation, which could be harmful to patients. Professionals should employ a decision-making framework that prioritizes code compliance and patient safety. This involves 1. Identifying the specific system being installed medical gas piping. 2. Locating and thoroughly reviewing all applicable codes and standards IFC, IMC, NFPA 99 if adopted by the jurisdiction. 3. Verifying that all materials, equipment, and installation methods conform to these specific requirements. 4. Ensuring all required testing and certification procedures are completed and documented. 5. Consulting with manufacturers and code officials when any ambiguity arises. This systematic approach ensures that all regulatory mandates are met, and that the highest standards of patient safety are maintained. Question 19. The assessment process reveals a plumbing system requires a valve to control the flow of water in a hot water heating return line where precise regulation of flow is necessary to maintain optimal system temperature, and frequent adjustments are anticipated. Which valve type is the most appropriate choice for this application, considering both functional requirements and common plumbing best practices? Option A. A ball valve, known for its quick quarter-turn shutoff and durability, making it ideal for frequent operation in general service. Option B. A check valve, which is designed to prevent backflow and is not intended for regulating or controlling the direction of flow. Option C. A globe valve, due to its design that allows for precise throttling and regulation of flow, making it suitable for applications requiring fine control and frequent adjustments. Option D. A gate valve, as it provides a full, unobstructed flow when fully open, and is generally used for on/off applications where minimal pressure drop is desired. Correct answer is C. A globe valve, due to its design that allows for precise throttling and regulation of flow, making it suitable for applications requiring fine control and frequent adjustments. Explanation. This scenario is professionally challenging because selecting the wrong valve type for a specific plumbing application can lead to system inefficiency, premature failure, code violations, and potential safety hazards. A plumber must not only understand the mechanical function of different valve types, but also their appropriate applications within the context of the governing plumbing codes and best practices for system integrity and longevity. The challenge lies in applying theoretical knowledge to practical, real-world situations where factors like pressure, flow rate, maintenance requirements, and the nature of the fluid being controlled are critical. The correct approach involves selecting a valve that is specifically designed for the intended function and operating conditions, adhering strictly to the applicable plumbing codes and manufacturer specifications. For instance, a gate valve is best suited for on/off applications where minimal pressure drop is desired and frequent operation is not expected. A globe valve, conversely, is ideal for throttling or regulating flow due to its design that allows for precise control. A ball valve offers quick shutoff and is durable for frequent use. A check valve is essential for preventing backflow. The regulatory framework for plumbing licensing exams emphasizes selecting the correct valve based on its intended use and the system's requirements to ensure compliance with safety and performance standards. This approach prioritizes system functionality, longevity, and adherence to established codes, which are paramount for licensed professionals. An incorrect approach would be to select a valve based solely on availability or cost without considering its suitability for the application. For example, using a gate valve in an application requiring flow regulation would lead to poor performance and potential damage. Similarly, installing a ball valve where a check valve is mandated for backflow prevention would be a direct violation of plumbing codes and a significant safety risk. Another incorrect approach is to disregard manufacturer recommendations for specific valve types, which often outline optimal operating parameters and limitations. Such choices demonstrate a lack of professional judgment and a failure to uphold the standards of the plumbing trade, potentially resulting in system failures, costly repairs, and legal liabilities. Professionals should approach valve selection by first identifying the specific function required, e.g., on/off throttling backflow prevention. Next, they must consider the system's operating conditions, including pressure, temperature, and the type of fluid. Finally, they must consult the relevant plumbing codes and manufacturer specifications to determine the most appropriate valve type that meets both functional and regulatory requirements. This systematic process ensures that the chosen valve is safe, effective, and compliant. Question 20. The efficiency study reveals that a specific section of a commercial building's potable water distribution system requires a transition from a 2-inch copper pipe to a 1.5-inch copper pipe, followed by a 90-degree change in direction. Considering the need to minimize pressure loss and ensure long-term system integrity as per the plumbing licensing exam's regulatory framework, which type of fitting would be the most appropriate and compliant choice for this transition and directional change? Option A. A standard 2-inch coupling connected to a 2-inch to 1.5-inch reducer and then a 90-degree 1.5-inch elbow. Option B. A standard 2-inch elbow immediately followed by a separate 2-inch to 1.5-inch reducer and then a 1.5-inch elbow. Option C. A standard 2-inch elbow connected to a 2-inch to 1.5-inch reducing coupling. Option D. A standard 2-inch to 5-inch reducing elbow? The correct answer is D, a standard 2-inch to 1.5-inch reducing elbow. Explanation: this scenario is professionally challenging because selecting the correct type of fitting is not merely about connecting pipes. It directly impacts the long-term performance, safety, and code compliance of the plumbing system. Misapplication of fittings can lead to increased pressure loss, potential for leaks, reduced system lifespan, and failure to meet the stringent requirements of the plumbing licensing exams governing regulations. A plumber must possess a deep understanding of how different fitting geometries affect fluid dynamics and material integrity under various operating conditions, all within the framework of established plumbing codes. The correct approach involves selecting fittings that are specifically designed and rated for the intended application, considering factors such as pressure, temperature, fluid type, and the specific piping material being used. This ensures that the system operates efficiently, safely, and in full compliance with the relevant sections of the plumbing licensing exams governing regulatory framework, which would detail approved materials, connection methods, and performance standards for various fitting types. For instance, a standard elbow might be acceptable for low-pressure domestic water, but a long-radius fitting, or a specific type of reducing elbow, might be mandated for high-pressure industrial applications or to minimize turbulence and erosion. An incorrect approach of using a standard elbow where a reducing elbow is required for a change in pipe diameter would be a regulatory failure. The governing regulations would likely specify requirements for smooth transitions to prevent excessive pressure drop and potential damage to the system, which a standard elbow would not achieve in this context. Similarly, using a threaded coupling on a system designed for solvent-welded joints would violate material and connection method requirements outlined in the regulations, leading to immediate failure and a significant safety hazard. Employing a T-fitting in a location where a simple coupling is sufficient and specified by the design would be an inefficient and potentially non-compliant choice, as it introduces unnecessary complexity and potential points of failure without a functional benefit, and may not align with the intended flow path as per code. Professional reasoning in such situations requires a systematic evaluation of the project's design specifications, the applicable plumbing codes and standards, and the operational requirements of the system. A plumber should first consult the design drawings and specifications to understand the intended layout and flow. Then, they must cross-reference these with the relevant sections of the governing plumbing code to identify specific requirements for fittings based on material, size, pressure, temperature, and application. Finally, they should consider the manufacturer's specifications for the chosen fittings to ensure they are suitable for the intended use and compatible with the piping system. This methodical approach ensures that all decisions are technically sound and legally compliant.